Alright everyone, it is kind of late, so I'm going to try to make this a short video, but it is a lot we have to cover here. So let's get started. First thing I want to remind you guys of is, do you remember the derivative of arc sine? Go ahead and take a minute, see if you remember. Yeah, it's something you need to have memorized, right? It is equal to 1 over the square root of 1 minus x squared. And if you remember, the derivative of arc cosine is just that, but the negative in front. Because their derivatives are so similar, you only actually have to use arc sine. You don't also need to use arc cosine. And so what we're going to do today is we're going to do, well, the opposite of that, right? So these are inverse trig, and instead of doing the integral of, the derivative is the integral, we're going to take the integral of this, and we're going to get that. And we have a little bit more generic form. So here they are listed for you. Of course, they're in a box, so you're going to want to memorize. That means flashcards, where this is on one side, that's on the other, right? You want to have these memorized. What you're going to do is notice that you start off with this this function, and you have a and u. A is a constant. U is actually generally something in terms of x, or well, it's the variable of integration, right? So as long as that matches there, you'll be good. And then the one thing you want to remember is u is always on the top when you're when you've taken the integral. And you just want to remember some of the little idiosyncrasies, like notice the 1 over a here, and then also absolute value bar when you're talking about secant there, okay? So yeah, these will be these kind of things to memorize. Notice it's a little bit of pattern symmetry here, but you just have to memorize them. So let's go ahead and I'll show you how this works. What I like to do is I like to write down what a and u are first, just to make sure I've got that down, and then I copy that down. So this first one, there's no square root, so that's going to be the integral that leads us to arctangent. Okay, so a here is going to be 5. Notice it's the first thing is a squared, so if a squared is 25, a is 5. And u is going to be 3x. Notice 3x squared gives us 9x squared, right? 3x parentheses squared gives 9x squared. So you want to make sure you find the right u there. And it's just about plugging it into the correct function. So we have 1 over a arctangent of u, which is 3x, over a, which is 5. And on the outside of the function is plus c, as we always have with indefinite integrals. And that's all it is. Okay, so what's the hardest thing here? Memorizing these, right? So you got these memorized, and it honestly helps. Like, you'll find in this activity, and even for your homework, you'll probably be checking back and forth between these, going, okay, which of these does this match? Once you have it memorized, it'll go a lot faster. So memorization also helps you there. If you have your constant, if you have a constant on top, doesn't really matter. You just pull the constant out in front, right? And so, I mean, if you want to rewrite it, 7 times the integral of 1 over, but I'm just going to do that and have the constant out at the end. This is a square root, so we're going to be using arc sine. So let's write down what a and u are. A in this case is 4. U is 9x. And so when we solve this here, we can get a 7 out in front. Then arc sine of u, which is 9x, over a, which is 4. Plus c at the end. Notice constants, so you can always just pull out in front, and it works out just fine, just like other integrals. And that is the next one. Let's get this out. There we go. All right, for this last one, this is the one that's a little different. You have to make sure, so you have a u out in, whoops. You have a u out in, nope. That's not what I want. I'm going to draw. There we go. You have a u out in front, and then u squared on the inside. So this is the one where all these others, a tends to come first. U will be coming first here, and it's a good hint if you see something on the outside of the square root right there. You want to make sure it is the same thing as that squared. Sorry, the front squared becomes that. So, but it works out in this case. So what is u? Let's write these down. U is 7x. Notice u squared is 49x squared, and a is going to be 2. So now we can just fill out. So we have 1 over a. It's 1 over 2. Times arc secant of, we need the absolute value bars, 7x up there, all divided by 2, plus c. And that is number 3 there. All right, we're going to move down into some others here. So let's move on down here. Here Here we go. I don't know why I left us so much space. That's all right. For this first one, we see, wait, 7 isn't anything squared. Well, it is something squared, right? The square root of 7, yeah? So what are we going to do here? Well, we're just going to put in, oops, give me a second, sorry. A is just going to be the square root of 7, because if you square that, that gives you 7, right? U is going to be 6x. And so now we can just fill it out. So we have, this is arc sine of u, which is 6x over a, which is root 7. Remember, you can leave roots in the denominator in calculus, woohoo, plus c. That's all we had to do for that one. For this one, we meet our first one where we're running into a little bit of a problem. Notice there's none of these, oops, there are none of these where x is in the numerator. You might try to play with this and go, hey, maybe I can get into the denominator. It doesn't work. And for another thing, no, there's no square root. So you know we're going to be dealing with this, right, arctangent. The question is, how do we get there? And the answer is u substitution. All right, so we've done a lot of u substitution, so it should be pretty straightforward. Thing I want you to notice before we get underway with u substitution is notice this. And I'll just put this in a little cloud here. E to the 2x is the same as e to the x squared. That's one of those things you want to be able to recognize and remember, right? And that's going to help us because that means that this here is, if we make u be e to the x, which is going to be helpful here, you'll see in a second, then we just need to have that recognize that that is going to be u squared right there, right? So we're actually substituting, we're not substituting out this one up here, you're going to see. That's actually falls out with the u substitution. So take the derivative, leave the inside alone, it's the same, and then derivative of the inside, dx. So what does that mean? That means dx is going to be 1 over e to the x du. And this is the one we're actually replacing. We're not going to replace the one on top because of this. So let's fill this out here. So we get e to the x over 64 plus u squared, remember, because of this deal up here. Dx, we're going to put 1 over e to the x du, and now you hopefully see why we didn't replace the one on top. These two are going to divide out. And that leaves us with just an integration, and we at 1 over 64 plus u squared, so we can now label our a and our u. So a is going to be 8. U is actually going to be u. That sometimes happens, right? Just making sure I label it so I recognize that. And so we get 1 over 8 arctangent of u over 8 plus c. But here's where it's very easy. We were like, we've just done so much. We're so awesome. All right, move on to the next one. We still have u. We can't end with that, right? We need to end with x. So come back here. We need to substitute out. So let me just rewrite it. 1 over 8 arctangent of e to the x instead of u. We substitute that back out there, right? Over 8 plus c on the outside. There is our final answer. Oops. Don't forget to substitute back out for the u, okay? I'll be honest, when I was making the notes for myself, I actually forgot that the first time. I looked back and went, ooh, I need to do that. Here it gets a little messier. Again, we don't have anything in the numerator here. You might even think, hey, maybe we could move it to the denominator. No, this is going to be another u substitution. The logical thing would be to pick tangent. The reason I want to pick tangent twofold. Remember, I need this thing in the denominator squared, so I need to have a u squared there later for this formula, the arcsine formula to work. The other thing is, the derivative of tangent is secant squared, so that's going to hopefully knock that out with the u substitution. So let's just do it, see what happens. Derivative is secant squared of x dx. So we solve for dx, we get 1 over secant squared of x, and now we're smiling to ourselves because, woohoo, it is going to knock it out. Let me write it down so you guys see that. Square root of 1 minus u squared, and then 1 over secant squared of x du. So we can eliminate that, those divide out, and we see that a is 1, u is u, that usually happens when you do some u substitution, and so we get arctangent, oh sorry, not tangent, arcsine, I'm still learning these two, arcsine of u over 1, which is just u, plus c. Well, again, we need to substitute back out, so u is tangent, so arcsine of tangent of x plus c. Now, I'm going to pause right here because oftentimes this won't be left like this. This will get solved even further, right? And so we just need to do a little bit of trig to make sure we have this. Give me just a sec. All right, sorry, I was getting actually mixed up. I thought for some reason that could be simplified to something. I think we don't have enough information there. So, yeah, I was thinking of something in pre-cal that we do, but that's the answer I'm going to end with for now. And if I figure out something else with that one, I'll let you know, but that's it for now. All right, coming on down here, now we get some other, we've been doing some u substitutions, so we're probably suspicious, natural log of x, I know the derivative is 1 over x, so let's see what happens. Let's make that be our u. That will work out well for, as long as we can get rid of that x there, right? And here's the deal, you can't do this right now as it is because, you know, that's not x. If it was x, then we could go back and use that other formula. But u is natural log of x, so du is going to be 1 over x dx, which means dx is x du. So, excuse me, let's come back here then and substitute this out. So we get the integral of 1 over x square root of 16 minus u squared. Instead of dx, we're going to have x dx, x du. And so these two are going to divide out, which is perfect because what's left over? It is the square root of 1 over square root of a squared plus b minus u squared. Sorry. Woo. So a is 4. U is u again. U are u. No. All right. And so we get arc sine of u over 4, but don't stop there because we need to substitute out the u. What was our u? It was natural log of x. So we get finally arc sine of the natural log of x over 4 on the outside plus c. All right, did I leave myself room for this next one? I think I did. I think I can. All right. So for this next one, the tricky thing here is if I start looking in here, I go, okay, this is most similar to the secant, right? Arc secant. I'd like for u to be 3x and a to be 4, but there's a problem. That needs to be 3x in front. Well, we can actually do that. Remember, constants are easy to change. It's the variables that are the problem. How can we do that? What if we added a 3 in front? You're not really adding a 3, right? You're kind of multiplying by it. That's really a 3 in the denominator. It's like multiplying the whole thing by a third. You can just pull a 3 out in front, right? So let's try that. If I multiply by 3 and 1/3, that's the same as multiplying by 1, right? So you see the 3's divide out, so you really get this. But look what we did. We just changed this to make it match what we need it to match, right? The kicker is we have this extra 3 out in front, right? So now we're good. Now we can use the formula and we can finish this off with arc secant. So 1 over a, which in this case a is 4, arc secant of absolute value of u, which in this case, sorry, is 3x. Let me do that. I'm not going to substitute that out later. All divided by 4 plus c. But one problem, watch out. This 3 out here in front, that gets placed out in front of all of it. So we really have a 3 times all that. Of course, you could instead put that right here, right? 3/4. And there is our solution for that one. Ooh, box it and send it away. All right, last one. I'll show you. This one stumped me for a little while until I started playing around with u substitution. Sorry, I said last one. We have a few more after this. Let's not try it in red. Let's try u to be arc sine. This is what I started off at the very beginning. What is the derivative of arc sine? Well, it's 1 over the square root of 1 minus x squared. Hey, look at that right there. I think something nice is going to happen to that. We do need our dx. So what? Dx is equal to the square root of 1 minus x squared times du, which means when we replace arc sine with u, we get 1 minus x squared times square root of 1 minus x squared du. Those guys are going to divide out right there. And we are left with integral of u du, which is just about the simplest integral you could find. Oops, keep Let's see, let's give some more space down here. There we go. So add 1 to the exponent, divide by 2. And we really do need to put it back in though, so we get arc sine of x squared over 2 plus c. So the kicker here was trying some different u substitutions and remembering that the derivative of arc sine is 1 over square root of 1 minus x squared. All right, here we're just doing a definite integral. It's actually just like you would think it would be. I did give you a nice one. Oops. Nice one here. So you see we can say a is 2, u is x. So we're going to have, when we take the integral, we do arc sine of u, which is x, over a, which is 2. But instead of plus c, this is a definite integral, so we're going to evaluate it from 0 to 1. And this problem is so kind. It gave us a little bit of trig to remember. So arc sine of 1/2 minus arc sine of 0 over 2, which is just 0. And so what is this? Well, here we go. Let's draw our triangle. Remember, arc sine, we're working backwards, so I'm trying to look for 1/2. I know that this is going to be, I don't need to draw the cube root. This is going to be the 30, 60, 90 triangle, or pi over 6, pi over 3, 90 triangle. I'm just going to do that for posterity. What is arc sine? Well, sine is SOHCAHTOA, so if I'm trying to get 1/2, 1/2 is right there. SOHCAHTOA is opposite of our hypotenuse, so the opposite is going to be this one right here. So I'm looking at pi over 6. Now remember, arc sine has a certain domain, but pi over 6 is for sure in it because it's in quadrant 1. It's not negative, so that's nice. We don't have to worry about that. So that's just pi over 6. Arc sine of 0, sine of 0 is 0, so arc sine of 0, the inverse is also going to be 0. So we get pi over 6 minus 0, which is just pi over 6. So that's one of the comments, is make sure you evaluate your signs. You can't leave it like that for your final answer. All right, for this one, I'm actually going to need a little more space. We'll write this off to the side. Sometimes you have to rewrite this as a sum of two quotients. What do I mean by that? Well, you know, this is just in my brain. I'm not writing it down, just in my brain, okay? You know that if you have like x plus 2 over 5, that's the same as x over 5 plus 2 over 5, right? That's how you add fractions, going this way, right? So you can also take apart fractions that way. Well, here, this doesn't match any of the things we've got. But we see that root 4, square root of 4 minus x squared, and that's like, oh, we could almost get that to arc sine. So what we're going to do, we're going to write this. I'm just going to break apart the fraction just like this, okay? So we have x over the square root of 4 minus x squared plus 2 over the square root of 4 minus x squared dx. You're like, okay, Mr. Newman, how'd that help? Well, now this one actually is, and let me actually, I'm going to write this. This one you're actually going to use arc sine on, okay? Arc sine, and it's almost there. We just need to pull the 2 out in front, right? Then it'll be arc sine. This one we're not going to use arc sine on. We're going to use, you guessed it, u substitution, okay? So let's go ahead and do that. Let's see. I won't color code it. In fact, I think I'm going to rewrite it over here. I'm going to write them as two separate integrals so we don't get confused, okay? So x over square root of 4 minus x squared dx. And this one over here is the integral. Remember, you can always do this. You can always break them apart if you're adding two integrals, the same as the integral of each part. Let's put the 2, I'll put it right here in front just so you guys see. I mean, it could go in front of the integral as well. 4 minus x squared dx. Let's tackle this one first. So I'm thinking u is going to be 4 minus x squared du negative 2x dx. So what is that? Dx, that means is negative 1 over 2x du. So let's substitute that out. So we get the integral of x over, notice I'm only doing this side. We don't need to do, in fact, we can't do u substitution over there. It wouldn't work. Square root of u, negative 1 over 2x du. Yay, the x's divide out. We're left with just u's, which is what we always need to have. So we get negative 1/2 integral of u to the negative 1/2 du. So let's add 1, negative 1/2, add 1, so you get u to the 1/2 divided by that 1/2. 1/2 divided by 1/2, we still will be left with a negative, but at least we're not going to have to do anything else there. I would put plus c, but we're adding this and we'll put plus c at the end of all of it, so we don't need that. So plus, so let's see what happens over here. Well, what are the two values? We have, we've got a is 2, u is x. So let's just go ahead and write this down. So we get a 2 out in front, right? And we get arc sine of u, which is x, over a, which is 2. And make sure we get a plus c at the end of all of that. Okay, now we're not quite done because we didn't do our u substitution back. So I'm going to go ahead and I'll go ahead and write this down. It was 4 minus x squared, right? So we have, whoops, give myself a little more space. We have the negative out in front, don't forget. So negative, parentheses, 4 minus x squared to the 1/2 power, plus 2 arc sine x over 2 plus c. And we are done. Ooh, look at all that. Some comments before we move on. And this is something I want you guys to get good at recognizing. And the more you practice, the more you'll get there. Recognize when you're supposed to use u substitution and when you're supposed to use arc sine. And notice how similar they are, right? And that really comes down to if you can memorize these, you can see these patterns. It's not always still, even though it's still not always obvious, because look here, something like this, we say, oh, there's e to the x in the numerator. Well, you can use u substitution to get that out, right? And then use that. Of course, we didn't actually use any arc sine on the left side here, right? That was just straight u substitution. So sometimes, and you want to be careful of that, make sure you don't automatically go to inverse trig. For example, this looks like a squared plus u squared. Problem, the sum, that's going to be arctangent. Look, there's nothing, it has to be a 1 in the numerator. You can't have a variable in the numerator and have that work. So unless we can use u substitution, which here you can't, okay, this is not going to change. We need to just, we need to see u substitution in general here, right? So instead of trying to make this match arctangent, u equals 81 plus x squared, I'm just going to use u substitution the whole way. So let's just finish this for the video just so you guys have the practice there. My voice is going, oh. dx equals 1 over 2x du. So we write this integral down. Oh, it's just u right there, right? 1 over 2x, the x's are going to divide out. And look, we don't need any inverse trig, right? What do we have? We have the integral of, let's put the 1/2 out in front, 1 over u du. I almost wrote u to the negative first. I've now gotten the habit of, nope, that is natural log of x. Natural log of u. So 1/2 natural log of u plus c, which is really, what's our u? It's 81 plus x squared. 1/2 times natural log of the absolute value of 81 plus x squared. In this case, the absolute value is redundant because this part in here will always be positive, right? And we are done. Thank you guys for watching.